So today we're going to learn how to solve an exponential equation. There's two ways to solve exponential equations, and today we're just going to explore one of those two options. First of all, though, we need to review the properties of exponents that you've used in the past. First, we're going to review multiplication of exponents. I'm going to show you a general rule that works for every time you need to multiply exponents, and then a specific example. So general rule for multiplication, remember B stands for our base, right? And M and N are exponents. If I have the same base, each of them have their own exponents, B to the M times B to the N, I'm going to add those two exponents together. My base number doesn't change, but I just simply add the exponents together. For instance, 4 to the 6th power times 4 to the 3rd power gives me 4 to the 9th power. Power of exponents. This is when I have one base and two exponents. In the last example, I had two of the same base, each with their own exponent. This time I only have one base, two exponents, and I multiply those exponents together. For example, 4 to the 6th power, that taken to the 3rd power, would be the same as saying 4 to the 18th power. Remember, that means I have 6 4's being multiplied together, 4 times 4 times 4 times 4 times 4 times 4, and I have 3 sets of those, which would give me 18 4's being multiplied together. Division of exponents. This again, I have to have a matching base or else this doesn't work. But if I have b to the m power divided by b to the n power, I can subtract the exponents. Numerator exponent subtracting the denominator exponent. For instance, 4 to the 6th power divided by 4 to the 3rd power would be 4 to the 6 minus 3 power, or 4 to the 3rd power. Exponents of 0. Anytime you have an exponent of 0, you get an answer of 1. It doesn't matter what our base number is, you always get an answer of 1 when you have an exponent of 0. Negative exponents. If I have a base number to a negative exponent, that's the same as saying 1 over that same base to the positive exponent. Same exponent, just change the sign. It's kind of like if somebody's giving me a negative attitude, I'm going to send them to the basement and my situation becomes positive again, right? My exponent only changes sign when I take it to the denominator. By the same token, if I have a negative exponent in the denominator, this is like if someone was downstairs giving me negative attitude, I would send them upstairs to make my situation positive again. So if I have a negative exponent in a denominator, I'm going to send it upstairs to the numerator and my exponent changes sign. For instance, if I have 4 to the negative 3rd power, that's the same as 1 over 4 to the positive 3rd power. Notice the base number didn't change, just the exponent did, and all it did was change sign. And by the same token, if I have 1 over 4 to the negative 3rd power, that's the same as 4 to the positive 3rd power. So one type of exponential equation that you can solve is when each side of the equation can be written using the same base. So I can have, for instance, b to the x power equals b to the y power. B has to be the same number. In this case, x and y must be equal, of course. Your base number has to be greater than 0 or else this doesn't always work. And your base can't equal 1 because 1 to any power is still just 1. So first thing we're going to do today is rewrite the bases as powers of a common base. Hopefully that'll make sense to you in just a second. For now, please write it down. Then we're going to simplify some exponents. Then we're going to solve for the variable, remembering that our exponents have to be equal in order to make both sides of the equation equal. So let me show you what that looks like. In example 1, I have 4 to the x power equals 1024. 1024 can be rewritten as a power of 4. So if I want to find out what power of 4 it is, 4 to the first power is 4, 4 to the second power is 16, 4 to the third power is 64, to the fourth power is 256, and 4 to the fifth power is 1024. That's the number I have on the right. So I'm now going to rewrite 1024 as 4 to the fifth power. Can you see why that would work for us? Because remember, in order for my equation to be equal on both sides, my exponents have to be the same, which means that x has to equal 5. And I'm done solving my equation because I needed to solve for x. In my second example, I have 1/2 to the x power equals 16. I'm going to do a little bit of changing my exponents around, right? A fraction's not really going to help me here. So I'm going to change 1 over 2 to the first power. Remember, 2 is the same as 2 to the first power, to 2 to the negative first power, right? 2 to the negative first power is the same as 1 over 2 to the positive first power. Now I'm going to use my multiplication property. Well, the power, right? Power of exponents property. And remember, when I have one base to the two different exponents, I can multiply those exponents together. And now I get 2 to the negative x power is equal to 16. I'm going to change 16 into a power of 2, and I find that 2 to the fourth power is what 16 is equal to. So I'm going to change 16 to 2 to the fourth power. Since I have matching bases now, my exponents have to be the same in order to make them equal. So I can say that negative x is equal to 4, or x is equal to negative 4. I'm going to use the same kind of example in example 3, or the same properties. 1 over 49, I'm going to change the 49 into a power of 7. 7 to the second power is the same as 49, so I'm going to change that a little bit. 1 over 7 to the second power is the same as 7 to the what power? The same as 7 to the negative 2 power. Since my bases are the same, that means to make this equal, my powers have to be the same, which means x needs to be negative 2. What do you think I need to do here in example 4? Is my base to the power by itself? Not quite, so let's add 8 to both sides and get that by itself. So now I have 125 equals 5 to the x power. It is going to be important for your power, or your base to a power, to be alone. Now I'm going to look for the power of 5 that is equal to 125. This means that I can change this 125 to 5 to the third power. What's x going to be now? Since our bases match, our powers have to also match. And x has to be 3. Make sure you write down any questions that you have so we can ask them in class. Remember to take the online quiz and bring your notebook with you to class. Have a great day, and I'll see you later.